Main words that we learned this chapter, sequence. You guys remember what that was? So that's just like a series of numbers. There's some kind of pattern between them. So the pattern on this sequence is +2, right? So this would be an arithmetic sequence if you have the same value over and over. And an arithmetic sequence has a common added value, and we call that the common difference, and we called it D equals 2. Okay, what's the difference between a sequence and a series? Series is what we did on Thursday, and it's almost the same thing, it just has pluses between them. Okay, so series just adds the terms together. So on a series they might say like, what's S sub 4? Like that means what's the sum of the first 4 terms in the series. So you'd have to do that plus that plus that plus that. You could say this is the 4th term, but when it says S sub 4, it means what's the sum of the first 4 terms. Anyways, so what's it called if you have a common multiplied value? Like 3, 6, 12, 24. That's called, yes, geometric. This would be a geometric sequence. The common value that you multiply, and if you can't tell what's being multiplied, you just do this one divided by this one, 6 divided by 3. We call that the common ratio. So on this one, the common ratio is 2. And today we're doing, this is a sequence, but today we're doing series. So we're doing the sum, like 3 plus 6 plus 12 plus 24 is more like what we're doing today. All right. So if it's a really short series like this, you could just add them together. But if it's a longer series, they figured out a formula, which I put on the board over there, but for the video, I'll go ahead and write it right here. And it's also in your book somewhere. On 539, I guess. I think, anyway, the formula's around there somewhere. So it's this. That is the sum for the first n terms in a geometric series. What's a sub 1 mean? That'd be like the first term. So just as an example, I'll use this one. So you do 3, 1 minus, what's R stand for? The common ratio, which if you're not sure what it is, it's what's multiplied to get to the next term. 6 divided by 3 also gives you the common ratio. In this case, that would be 2. What does N stand for?
No one knows.
Okay, it's the number of terms you want to add together. So if I want to add these 4 terms together, I probably wouldn't need this formula, but just for practice. So S sub 4, so 4 would be the N value on this one. By the way, if R is negative, and you want to take a negative to the 4th power, you would need to put it in parentheses like that. In this case, R is not negative, so we don't really need that. And then on the bottom is 1 minus R again, but there's no exponent down here. So you can just plug this in. I mean, this is a pretty short series, so it's not, you don't really need the formula for this, but pretty much everything we're doing today, you will want the formula because the series are pretty long. So this would add up to like 42. Okay. I'm probably forgetting something. I remember one thing. You can also do the sum of an infinite series if the common ratio is less than that. So, if I added an infinite number of terms of this series that I just did, well, it would get bigger and bigger and bigger forever and ever and ever. So if I try to add an infinite number of those terms, it would just head towards infinity. Okay, so when it gets bigger and bigger and bigger like that, when you keep adding, it would just go up forever. And so it does not approach any value, and you would say the series diverges. In other words, it's not approaching a number. There's no value that it's gonna get close to. However, if I do a series like this, I think this might be one of the problems today actually. When you multiply by a half, or really anything less than 1, what's gonna happen is the numbers that you're at keep getting smaller and smaller. So it's actually not gonna go up forever, it's gonna approach some number, and as you go towards infinity, it gets closer and closer and closer. Technically, it'll never quite get there, but it'll be like if this number was 5, it'll be like 4.99999. But the closer, the higher you go, like the more you keep adding, the closer and closer it gets. So it does converge. And if it converges, you're gonna say, what number is it approaching? And the formula for that is very simple. It's right over there also. It's a sub 1 over 1 minus r. Okay, this only works when the common ratio is less than 1 or bigger than negative 1. So it's got to be like a fraction, like positive 1/2 or negative 1/2. Okay, so on this one, my example was the ratio was positive 1/2. And you plug it into this little formula and it tells you what it's going to approach. Like magic. Okay. That's pretty much it. I think this is easier than Thursday. You guys can disagree if you want to, but we'll see what happens.
Do it on black.
When I do black, there's a glare and I can't see it very well in the video or in class. Because I did that a week or 2 ago and I had complaints. The glare didn't work. Okay, so on number 1, it says find S sub 7 for the sequence. I don't know why they didn't write it like a series, like 2 plus 5 plus 8. But basically we're supposed to add, am I on the right page? No. It's like that is an arithmetic. That was an arithmetic series. 3 plus 6 plus 12. Okay, here we go. And it's 8 now. Okay, now here's the right problem. Alright, so we want to add the first 8 terms together. So the little formula, it's over there. I'm not going to scroll up every time, but it's also right here. So what does a sub 1 stand for? The first term. So the first term is 3. Okay, what is the pattern on this? How do I get from 3 to 6 to 12? Times 2. So the common ratio is 2. Okay, what is the n value that goes right there? Well, yeah, it's always going to be whatever it's the number of terms we're adding together, so it's 8. And then on the bottom, you do 1 minus r again, but there's no exponent. And that's it. Just plug that in, that'll give it to you. This is a very large number right here, so I don't think I can do that in my head very well. 765.
How's your day been, Mr. Jordan?
Fine. We could have kept going out like this to the 8th term. I think it's just more work if it's like anything more than 5, 6 terms. It's probably more work to do that. Okay, anyways, number 3. S sub 6, 16, 24, 36. Okay, they're telling us it's a geometric sequence, like they are multiplying something, but how do we figure out what they're multiplying to get from there to there? You guys remember how we did this? What are they multiplying to get from? Right, 24 divided by 16. So depending on how your calculator is set up, it might give you 3 over 2 or 1.5. I'm going to use the 1.5. So we're supposed to find S sub 6. So I'm going to start with my first term, 16, 1 minus the common ratio, 1.5, to the 6th power, because we're adding 6 of those together, divided by 1 minus 1.5. So these should always look alike, this part, but there's no exponent on this one. How about let's try and plug that in, make sure we're getting the same answer. Make sure we understand how to use the calculator on this. I think somebody said their calculator was doing error when they did this. It might want a time symbol right there, but I feel like most calculators should do it without it.
Is it a decimal?
Yeah, 300 and something.
332.5?
Yeah. Okay, just want to make sure the calculator works basically, or there's no operator error. Okay, number 5, S sub 101. That's a lot of terms. Well, I thought it would be easier to do this one without the formula, but it did confuse the other class quite a bit. What is the pattern on number 5? Times negative 1. But it just goes 1, minus 1, plus 1, minus 1. So the sum of the first term is just 1. What would the sum of the first 2 terms be? 0. What would the sum of the first 3 terms be? First 4 terms. So you see the pattern. After an odd number of terms, the value goes up to 1. After an even number of terms, it goes back down to 0. So if you add 101 of those together, it would be back up to 1 again.
Yay.
You could use the formula there, it's just, you don't need it. Okay, number 7, determine whether each infinite, so we switch to infinite, that means we're switching to this kind of basic formula right there. Determine whether each infinite geometric series converges or diverges. Converges or diverges. If it converges, find its sum. Okay, you can tell whether it's converging, whether it's approaching a number, basically if your ratio, your common ratio is less than 1 or greater than negative 1. And also, basically the numbers kind of get smaller if it's converging. Because you have to add a smaller and smaller value for it to work. So, on number 7, the pattern is 4 plus 2 plus 1, plus 1.5, blah, blah, blah. So, what is the common ratio? 2 divided by 4? Yeah, 1/2. So, is it going to converge? Yes. It's going to, when you add smaller and smaller numbers, it will approach a limit. So we're supposed to say converges, and we're supposed to say what does it converge to? What number does the sum of these numbers approach as you add more and more numbers? It's called a limit. What number does it approach as you add more and more numbers? All right, so the formula, really basic. It's a sub 1 over 1 minus r. So a sub 1 is 4, first term, and we just talked about the common ratio is 1/2, so it's 4 divided by 1 minus 1/2. 1 minus 1/2 is 1/2. 4 divided by 1/2, to divide a fraction, you flip and multiply, is like 4 times 2. So the sum that it approaches is 8. If it diverges, so if this value, the common ratio was like 2 instead of 1/2, that means it would diverge, it would not approach a sum, it would actually like approach infinity. So anyways, number 9. Negative 18 plus 6 minus 2. By the way, on number 8, what is the common ratio? Kind of just talked about this on number 5. -1. Okay, is it going to converge if the common ratio is -1? The answer is no. So the sum is going to jump back and forth between like 1, 0, 1, 0, 1, 0. It's not approaching anything. It's just jumping back and forth between two numbers. So for it to converge, the common ratio has to be between -1 and 1. The value that you're adding has to get smaller. Or the common ratio has to be a fraction. Okay, number 9. -18 plus 6 minus 2. Okay, what is the common ratio? How do we get from there to there? 6 divided by -18 is -1/3. Is that going to converge? Yes. -1/3 is in that range. It'll make your numbers get smaller and smaller. The negatives will make it jump back and forth between positive and negative, but they still will be getting tinier as you go along. So it will converge. What does it converge to? Excellent question. A sub 1, first term, is -18. And we gotta do 1 minus -1/3 for the common ratio. So make sure you're doing minus -1/3, or you could say plus 1/3 right there. So it'd be like 14, what does that come out to? It's a messy one. And the answer is, oh, I was supposed to write converges too. So number 8 does not converge, so you're supposed to write diverges, and there is no number that it approaches. All right, you guys,
I forgot how to do sigma.
are we gonna giggle for 5 minutes
No.
about sigma today? I told the juniors you guys did that.
Do what?
Giggled for 5 minutes about sigma. They did not find it.
My bad. The only one that lasts.
The only one
Or supposed to define it. What? What did you find it? About the word. What did you find feeling about that word? What did you Google?
Sigma is fun.
Okay, so what it means, if you guys recall, is we're supposed to plug in 1 for k, and then 2, and then 3, in this case, all the way to infinity. And each of those terms is you're supposed to add all the terms together. So it is a series. So if I plug in 1, for example, 2 to the 1 over 3, that's just 2/3. If I plug in 2, the next one, 2 squared over 3 is 4/3. If I plug in 3, it'll be 8/3. So, and then we're supposed to go all the way to infinity. Now, can we actually go to infinity? No, but because, okay, is this going to converge or not? What is the common ratio? So what's 4/3 divided by 2/3? The answer is 2. So is this going to converge? No. So we're just supposed to write diverges. Basically, yeah, we're just multiplying by another 2 every time. So it's just going to get bigger and bigger and bigger. Does not approach a value. Heads towards infinity. To infinity and beyond. Number 13, identify each series as arithmetic or geometric and then evaluate the series. Okay, so they're saying some of these are arithmetic, some of them are geometric. We got to figure out which one, and then we have to find the sum. So on 13, what is the pattern? 5 plus 15 plus 25. What is that pattern? It's plus 10. Why is it not times 3? Because 15 times 3 is not 25. But if you do plus 10, that does work, right? So what kind of series is it? Arithmetic. Okay, and then this part, I'd be shocked if anybody remembered. On Thursday, we had a formula for the sum of an arithmetic series. Anybody remember that one? I didn't write it on the board today. I'll put it over here. It was number of terms divided by 2 times a sub 1 plus a sub n. So a sub 1 is the first term. A sub n is the nth term, like however far you're going, the last term. Okay? This is what we did on Thursday. So 5 plus 15 plus 25. All right, so how far are we supposed to go? 17?
Infinity.
No, we're not doing infinite anymore. We're doing 17 terms. Okay, if I add the first 17 terms, n is 17, so we would do 17 divided by 2. A sub 1, first term is 5. Okay, how do I figure out what the 17th term is? Writing 17, this would be the 17th term. This is what kind of made Thursday a little bit hard. If the first term is 5, how do I figure out the 17th term? Right, how many, so the pattern is plus 10. So how many 10s would I have to add to get from the first to the 17th term? How many times would I have to add 10? 16. Because from 1 to 17, the gap there is 16. So I'd have to add 10 16 times. You guys remember that?
Yeah.
So it'd be like 165.
Do you want us to write arithmetic?
Yeah, the arithmetic is part of the question, yes. So arithmetic's one answer, and whatever comes out of this is the other answer. What's that? 1445.
Wow, you're so good at that.
Thank
Did
you.
you even look at the book?
Yes.
Oh, you could do that if you tried.
No, I didn't.
Tap into your Asian skills.
That's like what I
Oh,
mean.
that's-
That was a little racist right there. I'm canceling you.
You can be racist if you're complimenting people. Just
No,
can't
you-
insult.
Only West
See,
Shannon-
I was
Shannon knows how to
complimenting that
use
kid
very
with
good
long
spices.
eyelashes.
Still
You said
racist.
you took another.
No, it was the other kid.
Oh.
A white kid, right?
What?
He's a stupid ugly kid who's white, right?
No, he's Indian.
That's
Oh! No, that's racist.
She didn't say he's ugly, she said something about his
No,
eyelashes.
She did say it.
No, I said I hate him, and then I said he's Indian with long eyelashes.
No, you just
She
said.
said he's ugly and I hate him.
Yeah.
Okay, but I didn't say he's
This is
ugly.
Bro, Shannon is so offended
I
by
said he
that.
had long eyelashes because he was Indian.
So you said he was ugly and stupid.
But that didn't have to do with him being Indian.
Right.
Yeah, I did.
No, he had long.
No.
I said Indian after. I said he was stupid and ugly.
Yeah?
This is
That's
racist.
racist.
No. I
Okay,
said he had long
anyways,
eyelashes.
I'm sorry I said anything, my bad. It's my fault. Okay, number 15, what's the pattern? 2 minus 6 plus 18. You guys see what the pattern is on that one? Times 3, negative 3. So if it's alternating between positive and negative, that has to be times a negative, right? Because when you multiply by a negative, 2 times negative 3 is negative 6, negative 6 times negative 3 is positive 18. So if it's multiplying by negative 3, then it is a geometric series. So that's one answer. The other answer is, what's it approaching? We're going to use the formula from earlier, so I'm not going to rewrite it. But the first term, how many are we adding, by the way? 19? Okay, so the first term is 2, yeah. And then we did 1 minus the common ratio, that's what Shannon said. So you gotta be careful on this one. Actually, if you plug this in the calculator, it would be right. However, if we were doing 20 terms, that would be wrong. You guys know why that would be wrong? Yeah, so you want to do the common ratio to the n power. So if that negative would be included in the r value. So anyways, just to be safe, you might want to just put, if there's a negative right there, you might just want to put parentheses around it. Now, if you have an odd power, it's going to come out negative either way, so it doesn't happen to matter on this one, but if it had been an even power, it would matter. So just to be safe, you might want to put parentheses around that, but
Yeah, really big
I don't
number.
know if that makes sense. Yeah, some of these are very big
I
numbers.
got a really big number.
This one is 581 million.
That's way bigger than 14.
14 is over a million also.
Yeah.
130,000.
But it's not yet. Eli, how are you doing over there? What are you doing? Sure, words have never been spoken. Probably.
He's living the dream.
Eli's like a parabola. Living life in the moment. Until it goes downhill.
You're making no sense.
But like parabolas, they go up or down.
Okay, on 17, back to sigma notation, we have to figure out what the sum of the first 15 terms is. We don't really need to plug in k equals 1 to 15. We can just do a couple of them. If we plug in k is 1, on 17 we get 3 times 2 to the 1, which is just 6. If I plug in 2 on 17, it's 3 times 2 to the 2. 2 to the 2 is 4, times 3 is 12. If I plug in 3, just one more as an example. If k is 3, 3 times 2 to the third. 2 to the third is 8, times 3 is 24. So what is the pattern on 17? Yeah, it's times 2. Why is it times 2? Because in the formula they use, you're doing 2 to the k. So every time k gets bigger, you multiply by another 2. That's what makes it happen. Anyways, so these are geometric series. They're not really asking, but we do need to use the geometric formula that we just did. So, we're adding how many terms together on 17? 50. So we're going to do the first term times 1 minus the common ratio, which is 2, to the 15th power over 1 minus the common ratio.
Sorry.
196,602.
Forrest, how are you feeling?
It's getting a little warm in here, isn't it? Or a lot warm in here.
It's been warm in here.
Ever since Forrest walked in the room.
Warm.
Just
Just really warm. Sorry.
Well, there.
Pretty sure it's warmer outside than it is in here too.
That might be why the history room is so warm.
It's supposed to be like 80.
Turn the air conditioning on. It's not even that warm in here. Oh, shut up. Nobody else.
Hey, but you're a horrible person.
It's a little bit warm.
Dude, she
Ever
says
done these
it's,
before?
it's not cold.
Okay, number 19. If I plug in 1 for k, it would be negative 72 times negative 1/6 to the 1. So negative 72 divided by negative 6 is 12. If I plug in 2 for k, it'd be negative 72 times 1/6 squared is 136. Negative 72, basically divided by 6 twice. is -2. And if I plug in 3. So every time k gets bigger, you're multiplying by another -1/6. So what is the common ratio? Well, -2 divided by 12 is -1/6. So that number in parentheses, because the k is there, that's the number that keeps getting multiplied over and over. So that is the common ratio. Alright, so when I plug stuff in, how many terms are we adding? 5? That's not very many. Okay, the first term is 12. The common ratio is -1/6. And we're doing 5 of those.
What's your favorite sport?
Football.
Yeah.
Amen. What's
What's your
wrong?
favorite fruit?
I think some people don't understand.
Ooh. I don't have a favorite fruit.
What's your shoe size? What's your
Yeah,
favorite?
it's so good.
Right?
Alright, this one, 10,280. Oh. The directions do say round to the third decimal place. So if you get a fraction, change it to a decimal. Going to the third decimal place, the thousandth place in that section.
What if it rounds like an odd number? Do we round it up?
None of them